So it is a great pleasure for me to turn this over to our speaker, Cecilia. Thank you for joining us today.
Thank you so much, Betty, for that lovely introduction to all of you here who are joining us today. I'm really delighted to be talking with you about this topic, and we will have plenty of time at the end for Q&A. So I'm just going to get started here. So this presentation involves AI, and when we can think about what is AI, well, it involves the software and computer code that's part of creating the AI systems. It involves the hardware that embed AI. It involves the mathematics, algorithms that are the underlying the AI and that we use to create AI systems, and then also the metrics that we use to evaluate AI systems. And then, for example, robotics is part of this as well. Could be industrial robots or other forms of robots. And all of this is part of what when you are learning about AI, that you can, all these are aspects that you will develop skills and knowledge in. In addition, humans also play many roles in kind of the broader AI ecosystem. So, for example, AI systems are often developed on data that has been labeled or annotated by human annotators. We also have developers who are preparing code to create and maintain AI systems. And once these systems have been deployed, we have the users who are engaging with and using the systems. And these systems are now entering into, they're in our homes, they're in our work environments, and they're becoming quite pervasive across society. And policymakers are also thinking about AI and how to regulate AI. So the human component is very important. So there is this increased attention to AI. There have been some breakthroughs for example, that have made AI systems such as ChatGPT and other AI systems that you've interacted with possible. There we have better hardware, more compute, we have access and the ability to process large data sets. And there have been some technical innovations, such as deep learning transformer architectures, for example. AI is a very large field. So here I'm just doing a kind of a snapshot on what's happening in language technology, which is an area that I work on and also teach classes in. And, we have, for example, on this in the space of text and text processing, we have ChatGPT. We have, for example, translation systems like Google Translate. There are particular models. They're called, for example, BERT is a well-known large language model, and so on, and different kinds of models. Chat and GPT models are, of course, among the most well-known ones. In the speech space and the dialogue system space, we have, for example, Amazon Alexa, we have Google Nest, we have closed captioning technologies and so on, so kind of go from speech to text. There's also a great interest in developing more language technologies for signed languages. And oftentimes nowadays, language technologies are also part of that multimodal space that involves language and other modalities, often human modalities, or other forms of information and data that has similar properties to language, such as computer code, for example. So we use these systems to generate, to summarize, to translate, transcribe. They can synthesize information for us. We interact with these systems. They can help us. They can help simplify information. They can help creating and also they, I think, inspire us as users. So and there have been similar leaps like the ones that I kind of mentioned here for the space of language technology and computer vision and in many other core AI areas. Whoops. Okay. So, all right. So there we go to the next slide. So one way that AI systems can be created nowadays is also to use pre-trained models that have been developed from very large data sets. And we may use those as a base or a springboard and then fine-tune these data sets with smaller, fine-tune them with smaller data sets to solve specific additional tasks. And when we're thinking about creating AI systems, there are many pieces also in what the implications are for society. So there's a lot of thoughtfulness that goes into that creation of AI systems. For example, AI systems may require a substantial power consumption to develop, and training them can take a long time. So that's one of those areas. So it's important to have that well-rounded perspective when thinking about AI. So here's a roadmap of my talk today. I'm going to start by talking about the Masters of Artificial Intelligence in the School of Information at RIT. And then I'm going to go on and talk about Aware AI, which is a traineeship programs that's across the disciplines, also at RIT. If I have time at the end, I'm going to also talk about another initiative at our university. And then I'm going to sum up with some insights for thinking about AI preparation. So let's start with a Masters of Artificial Intelligence at RIT. I put a link here in this slide, but I think Betty has also added it in the chat, so you can click on that and review information about the program. So why a Masters of AI at RIT? Well, there's an enormous and growing demand for AI professionals. And this particular program teaches students to harness the benefits of AI and gain transferable skills in the responsible and impactful design, development, analysis, and deployment of artificial intelligence. The program also offers customization with specific electives that are focused on central AI themes. And at RIT, we also have very strong relationships with industries and a long record of these partnerships. So students can also, which are paid internships, support these co-op opportunities and preparing for them is supported by designated staff in RIT's Office of Career Services and co-op. So the Masters of AI is a unique master's program. It's a joint program that's delivered by faculty experts from 4 different colleges. It's housed in the B. Thomas Golisano College of Computing and Information Sciences in the iSchool or School of Information. And then other colleges are also involved. So College of Liberal Arts, College of Science, and the Kate Gleason College of Engineering. And you see some of the faculty that are involved in teaching some of our core or bridge classes or otherwise involved in the program. We also have a designated academic advising staff and other staff for this program. And we have, in our coursework, students have the opportunity to engage in experiential learning through coursework in their program milestone and so on. The kinds of positions that graduates from this program may enter into include, for example, AI or machine learning engineers, technology analysts, AI policy specialists, software developer, or more specific fields like computational linguists. And this program is also opening up pathways for PhD programs in related fields. For example, computing and information science, cognitive science, and so on. Here's a broad curricular outline of the program. There are core courses in which students develop essential skills for this well-roundedness in AI. And then there are electives, and there are multiple electives so that students can customize their experience and develop depth in special interest areas by completing these electives. There's also that culminating larger milestone, which is the capstone, participating in a capstone project course or completion of a thesis. So students can have an option at that point. If they do the capstone, they can complete another elective compared to the thesis. So here is an overview of the MS in AI program. One of the additional things that we did is to introduce some bridge classes so that students are coming from different backgrounds, and students who need that, who, for example, may not have had enough experience of programming before this master's program, or who might need to boost their skills in mathematics for AI, would complete these classes before starting the program. Then we have the core courses, which are where the program really starts. And these are the 5 classes: fundamentals, mathematical in AI, mathematical methods for AI, ethics, which is an important area, the fundamentals of machine learning, and research methods for AI. And I mentioned also that students can optionally complete a co-op. We also then, after that, students further in the program, also the students can enter into various electives: machine learning, natural language and speech processing, robotics, vision, socio-technical analytics and policy in AI, and neuromorphic computing are kind of the thematic areas. And below those areas, there are multiple classes. And students could also take electives from across different of these kind of thematic groupings of courses. And the first elective is actually already in the 2nd semester, where students have the opportunity to already start customizing their degree. Then we also have this culminating milestone I mentioned, either the capstone course or a thesis. We currently have an in-person program that's already active at RIT, and then we are for this coming fall, we're also starting the program in its online modality. So we will have an online modality for this program starting in fall 2024. At RIT, we are also well known for our accelerated bachelor's and master's pathways, and we have such a pathway, BSMS, it's called, with psychology already in place. In the process is another BSMS option with economics, and then we are expecting one with applied statistics. And then we focus also on, community building, providing opportunities for students for growing networks, and so on. Here you will see some of the facilities that are in the School of Information in terms of teaching laboratories, for example, maker spaces, and so on. And here you will see some of the facilities for research that faculty and students are engaging together in researching in the School of Information. We also have a wonderful new building that's called The Shed. It's the student hall for exploration and development. I think one of the links that we included also is to The Shed, where you can see what it looks like outside, because it's a truly spectacular building focused on students and student use. And here you see one of the classrooms, one of the iSchool classes that are taking place in one of the new classrooms of The Shed. So that was what I was going to say about the Masters of AI that's housed in the School of Information at RIT. Now I'm going to go on and talk about another initiative at RIT, which is about research training for graduate students in AI through the Aware AI program. And this is an NSF-sponsored program where students from 18 different graduate programs, 18 different PhD and master's programs at RIT can choose to participate in. So the program is focused on, it's a research education integrated program. There are around a dozen different educational training elements, and there are also 4 research tracks that students who become trainees in this program participate in. So this is extracurricular, and the students apply to do this in addition to their degree programs. So one of the degree programs is, for example, the Masters of Artificial Intelligence and some other programs in the School of Information. But it is broader and across the university. Around 50 new trainees are in the incoming cohort on average each year. And we also have been fortunate to work with a partner in Ireland to enable some mobility exchanges. So we have currently 4 PhD students at ML Labs in Dublin, for example. And of course, I want to thank the NSF for supporting this program. So I mentioned it's a research education integrated program. So trainees experience career advancing activities and events and convergent research with faculty towards 4 trainee learning outcomes as listed here on the slide. Trainees are coming from multiple disciplines, as you can see. We're 18 programs at the moment. Next, in fall 2024, we will be 19 because we have a new PhD program in cognitive science at RIT, which is also an interdisciplinary program. We especially encourage graduate students who are women, deaf and hard of hearing, African American, Latino, Latina American, and Native American to apply to this program. And these traineeships are also an opportunity to grow one's network in a research community. Aware AI aims to enhance skills and knowledge in a number of different areas. Here are some of them through different kind of traineeship elements. So, for example, students develop more knowledge about human factors in AI by taking a course that's called Human Factors in AI. They participate in cross-track lab rotations to develop multidisciplinary flexibility. We have an internship partnership program that enables students to experience working with real tasks, real data, and so on and so forth. Here are the 4 research tracks in AI that are being pursued through this program with very cutting edge and state-of-the-art research. So, for example, the AI software track, as you can see here, we have the AI hardware track, we have the human-computer interaction for AI and cognitive modeling for AI as well. And we have multiple faculty members who are participating in each of these AI research tracks together with students. And working with students and guiding them. So here we have some examples of trainee research projects that are happening in these 4 research tracks. So, for example, in the software track, students are working on multimodal machine learning and cross-modal generative models. In the human-computer interaction track, the focus is on accessibility and automatic speech recognition technologies for older adults with hearing loss. In the hardware track, one student is working, for example, on reinforcement learning and interesting algorithms in that space. And also in the cognitive modeling track, we have a student working on spiking models that are inspired by the human brain and mind. Here you can see an example of what a traineeship semester can look like. So this is from a fall semester. And as you can see, some activities happen throughout the semester. So for example, research tracks activities take place throughout the semesters. We have this course in human factors in AI. There is a trainee council that where trainees, 4 trainees are engaging in developing their leadership skills by being representatives to the executive committee of the Aware AI programs, and also participating in various activities, could be outreach, helping faculty plan events, and so on and so forth, so that they benefit the students and correspond to student interests. So the trainee council is a good leadership opportunity for students. Students also participate in attend research talks through one of our research centers at RIT. We have workshops. Some events happen at particular times of the semester. So we have various workshops. We have hackathons, mentor cafes. We have lab rotations that take place over a couple of weeks. And we have multi-day events like an onboarding boot camp. And then in the spring, we have a winter retreat that is also a multi-day event. Students have the opportunity to apply for seed grants and gain grant writing experience, for example. Many of these activities are also open both to the trainees and the trainee cohorts, but also to other students, graduate students at the university. So they welcome broad participation. And then we've also been fortunate to receive a supplemental funding in order to enable mobility experiences abroad. So here are just some pictures I'm going to show from activities. So, we've had, for example, workshops in essential skills like teamwork, communication, and ethics. Students can gain opportunities for seed funding, as I said, and dissemination opportunities, conference attendance, and so on. We organize hackathons where students work in teams on a challenge. Is kind of friendly competition in those teams, across those teams. We have some multi-day events I mentioned that focused both on technical tutorials, such as, in this case, there was a reinforcement learning tutorial, as you're seeing here, but also professional development skills, such as learning about entrepreneurship topics. And we also invite researchers to either to these multi-day events, such as either researchers who visit us at RIT or who deliver talks and meet with students online. And, other tutorials, for example, might be more about methodology in addition to technical the technical tutorial I showed you before, for example. We additionally do roundtables. So, for example, we have a roundtable on grant writing every year. We do roundtables on advanced AI topics, such as, in this case, as you're seeing here on the slide, it was about AI on the edge and human-robot and human-robot interaction. We have mentor cafes, and in the spring, we co-locate this with another wonderful event, which is RIT's Graduate Education Week. And this is an opportunity to network with faculty and to gain insights and tips about research careers. And another highlight of the year, I would say, is in general at RIT is Imagine RIT, our Innovation and Creativity Festival, which brings tens of thousands of people to campus to see what is happening in STEM, in research, in technology projects, and so on. So, and our trainees participated in an exhibit at that creativity festival. So we have here are some what we're interested in also is seeing gains. And I mentioned that we have some AI areas that we're trying to advance. So what you're seeing here in this plot are pre-post measurements for basically before the students started and when they ended. And we have about 15 targeted areas that we're looking into. And as you can see, there were gains in those areas. So we were pleased to see that. We're just in our second full cohort year, so we still have time to go. And then we also have another nice result was that 100% said that they would recommend the program to peers, and 78% rated the program as extremely inclusive. Our external independent evaluator also looked at, and her team looked at constructs in this area and saw, for example, significant pre-post changes with large effect sizes that related to knowledge, communication, teamwork, career and professional development, and self-efficacy. And the area of scientific identity was also significant, but without that meaningful large effect size. So some areas that we wish to develop and improve involve scientific leadership and ethics, for example. And then I mentioned actually that students participate in seminars of the center, and this is the Center for Human Aware AI at RIT. That's a research center that involves over 25 faculty members with research that's being supported and funded by research grants from multiple partners, as you can see here on the slide. And it involves numerous research labs as well, as you can see here on the slide. So you can go and take a look. That link was shared by Betty in the chat as well. We have these regular AI seminars that with plenary research and advanced PhD student talks. We have an AI list with announcements on learning opportunities. And the center really focuses on, you can read the missions and goals on this slide, but it really focuses on areas such as the 4 pillars include human-centered AI, machine learning and perception, brain-inspired computing, and automation, and research within those 4 pillars. I can't talk about all the research that's happening in the center, but I will give a little bit of an overview of some work that is happening in my lab, where we're focusing on human-centered AI, including interactive machine learning. So, for example, that involves really the whole system, as you can see here, as you can think about it as a cycle. So we have students who are working on the front end, and this student is working on a data annotation demo, for example. I'll run the demo a little bit on the background, so that users can interact with the system and provide label data, for example. Much of the work that we do also doesn't involve, we don't have data sets yet for the research that we do in our lab. So we often collect our own data as we work on often heavily multimodal data collection. And here you can see, for example, some work that's done by a PhD student that collected data that involved dialogue, facial expressions, body posture, movement. The person who is building is also wearing some eye tracking glasses, and eye movements are being collected. And once we have those, we're also working on tools for analyzing such data. So here's the software application that was built by a web-based application that was built, that's being built by some REU students, research experience for undergraduates, funded students, undergraduate researchers in our lab to help researchers with tools to analyze data. A lot of the work that we do is on that back end with developing machine learning models for predictive systems and so on. And we work especially in this interactive machine learning framework, but also more broadly with various machine learning frameworks. So, for example, this PhD student has worked on different interactive machine learning techniques, such as active learning and machine teaching, as well as other frameworks in machine learning. And this PhD student here is working on, Cedric is working on human factors in interactive machine learning, and how both considering both the user interface design aspects and how that relates back to the models and model performance. So those are a couple of things that we're doing. So I'm going to wrap up by just thinking a little bit about what could be on the AI horizon. So we have, I think that what we're going to see more and more are multimodal AI. So capable multimodal AI, an AI system that manifests and have human-like flexibility. So, for example, that's something that we're working on. Oftentimes AI system kind of, if you're multimodal, for example, they expect all that multimodal input, but humans are very flexible. We can adapt, for example, when one modality isn't available anymore. If suddenly my video would stop working in this talk, you would still be able to follow along in the talk and listen to me as I'm developing as I'm presenting to you. So, and we want to, we're working on AI systems that should also have that kind of human-like flexibility. Increased human AI teaming, more and more humans and AI working together and mixed initiative systems, for example, in the creativity space. We're going to see some more core AI breakthroughs and leaps forward for sure. AI is going to spread further across disciplines, professions, and applications. The design and user interfaces for AI is another important area for research and development. And then AI regulation is also an area that's important in this space. So as we're thinking about preparing for AI professions, so we talked about, the programming, software, hardware, and we talked about, for example, the mathematics and algorithms that are underlying AI, and all of those are very important in preparing for becoming an AI professionals. And also that human components. Humans are really at the heart of AI research innovations, from users to policy to the creation and development of AI algorithms. So here are some insights to sum up the talk for AI preparation. It's important to grow and diversify the AI workforce, to develop skills and knowledge from multidisciplinary and interdisciplinary perspectives in AI, and to build holistic AI competence and well-rounded preparation for the AI profession. So I will end on those words and just point you again to some of the links that I think you have seen in the chat, and maybe we can put those links in the chat again in case anybody joined us after they were added there. I want to acknowledge the NSF and others, and answer any questions you might have. Thank you.
Thank you, Cece.
I think we have plenty of time for, we have plenty of time for questions. I think 20 minutes. So.
If anybody would prefer to unmute and ask a question, please feel free to.
Yes, please do. Or any thoughts or sharing about what's happening at other institutions.
No questions? You did a great job. Thank you so much for the presentation today. It was really great.
There are questions in the chat.
There's a question in the chat. Okay.
There too.
Oh, there we go.
Okay.
Are you planning to have a PhD program in AI?
So are you planning to have a PhD program in AI? We have a PhD program in computing and information sciences at RIT. And so there is already a program in computing and information sciences. For example, I referred to a couple of PhD students when I had a slide about my lab, and those students are in that PhD program in computing and information sciences. So that's where you will see AI, but you will also see AI in other. There are several engineering PhD programs. I mentioned also the cognitive science PhD program. So again, it's AI is really spread out across the disciplines in the PhD and research space at RIT. We are a technical university, and AI is widely distributed across the university. And as we're also leveraging that in this master's program for artificial intelligence, which is a joint program across the university. In terms of information about the foundational courses, what I would recommend there, that's the second question, is to go to our website and look at the at the courses, and then you can click and read the course descriptions and see and learn about what the topics are that are covered in those classes.
Good questions.
Yeah. Anything else? Maybe we can stop sharing we could turn off the video